Alright guys, welcome back. We're back in the world of Netcode this time, and we're going to be talking about client prediction this time around. And this is something that a lot of people come to Netcode for Entities specifically for, is the built-in client prediction system. So there's a lot to actually go over here, so we'll just go ahead and get started. The prediction system itself is built in and kind of always running. The prediction simulation system group runs on both the client and the server. The way this works is basically your client is going to be simulating running all of your commands like immediately. So when you press the fire button to fire or jump or whatever, it is going to immediately run that command. It's not going to send it to the server, wait for that to process and come back. It is just going to immediately do the thing. Now, what will happen if something on the server side denies that movement or whatever, then the system on the client side, when it gets that update, will have to roll back and resimulate with the correct world state. So all this like resimulation of physics and whatnot, it does come at a cost. And you'll be running at, it says here in the note here, like for a 300 millisecond connection, that's 22 frames of resimulation. Now, 300 millisecond ping time is borderline unplayable. I don't think I've ever had a game that ran stably at that slow or poor connection speeds, but it is technically possible, and you'll want to cover for that possibility if you're dealing for mobile, you're on Wi-Fi or whatever. Things happen. The internet gets janky sometimes. But this resimulation is all done on the CPU side. So that's something that you'll have to keep in mind. There are certain settings that we can set in order to test this in the multiplayer tools window. We'll show that in a second. And yeah, so we'll get down into here some of the actual code to tell the system which entities to simulate and which ones not. Because the interpolated ghosts, if you remember from last time, those are running on the server. Since the server is authoritative, it is not doing any rollback or resimulation there because it is the canonical truth. For your inputs here, I think last time we did end up using the server tick for our input, but last time I was using a older physics tutorial from their GitHub, which hadn't been updated to the new stuff. We've set that back to the iInput component, I believe it's called, that has the server tick rollback built in. We're not going to get into the prediction smoothing or prediction switching right now, but generally the gist of this is that when rollback does happen and you don't want your objects and players to just be like rubber banding around or teleporting in the worst case scenarios. So what this will do, this system will handle the lerping for you during the prediction smoothing. Same with prediction switching. You can switch between the predicted ghost modes and interpolated. So, like I said, the interpolated modes are kind of owned by the server, and your predicted ones are the ones that your client will control. So, say you have like a soccer ball or something that you want to interact with, it's going to originally be owned by the server interpolating, but if you want to interact with it, you want to kick it or whatever, then you'll need to switch it into the predicted groups. When this happens, your interpolated objects, their ghosts, are going to be behind. Is literally in the past because it's running on the server. Your client side is predicting ahead of what the server is actually on right now. That's called client prediction because you're running ahead of the servers. So the amount that you are ahead of the server is your ping time. When that switching happens between interpolated and predicting, then you are 2 times your ping ahead of what the interpolation ghosts are. So the switch prediction smoothing will kind of lurk between the 2 positions so you don't see them just snapping all over the place. This is a neat graphic here that I found on the internet. Kind of will show you what is going on here with the incoming server state, where the clients are, and what happens during like a rollback here. So like in this particular snapshot here, the client is currently predicting tick 207, right? The server is constantly giving the clients updates of, the true authoritative state of the world, but that update is a little bit slower, farther behind than what the current client is simulating. So when the client gets confirmation of what tick 202 really was, then the client will have to go back to tick 203, resimulate back up to 207. So each of these states are kind of held in there is a physics world history component that has the state of the world for a certain amount of time. And the slower your ping connection is, the larger simulated states you'll have to end up resimulating. So let's jump into Unity and just run a little demo here of what this actually looks like. We did do a little bit of updates here. Where is our player? Here. So what I did here was we removed the player authoring, player input, and our velocity move speed component here. And then we combined them all into this character controller. We'll go into some of the code in a little bit, but this is using an aspect that will combine a bunch of components to make queries a little bit easier for us. So let's go back to our main menu. Here, nothing here changed. Did just have a new scene we called Rollback. It's just a clone of our physics scene. Added a couple of different components for a target, and we're going to shoot them with a raycast. Here we go. So what we have here is we're going to shoot our target here. You'll see a green X and a red plus. The green X is going to be what our client sees, and the red plus is the same hit where the server is seeing it. So you can barely tell, but there is a little delay here. So the raycast is fine if they're coming right for us. But if they're strafing, you'll see a couple of times, if I'm late, well, I guess it'll actually be better if we add some lag. Sometimes I'll hit on the server and miss on the client, and vice versa. And this is with the rollback enabled. So we can uncheck this, and now we don't have any rollback delay compensation. And you can see here that the delay is not being caught up. So sometimes I'll hit, but it's in a completely different spot on the server side because that whatever our lag is set to is not catching up. And this will be worse the faster things are actually moving. We can really see this. This is 20 milliseconds. So that's some of the best pings you're ever going to get is that. But if we have in our tools here, we can say international, right? You're playing from someone across the pond. You'll have to lead the player that you're shooting in order to get a hit. And it's doable. You can get used to this kind of delay, but it's not ideal. So we turn the rollback back on, and then we can even make it an average international speed of 242. Oh, that just completely broke that. It's a little bit better. Not by much, though. But I can at least aim at the target and get some hits in. All right, so let's go through and see how we actually did this. All right, so we changed our input back to the input component data. We actually don't need this input tick anymore. Everything else is the same. I think I did add a secondary fire here. Not actually doing anything with that just yet. Our player input system has changed a little bit because I'm using the mouse to look around. We didn't have a camera system set up before. And this is using the input system before. Our look is mouse delta. Here. I did create a new player controls input action in order to change some of these processors. The scale vector processor is basically your mouse sensitivity. Without this, your mouse is way too sensitive to actually use. But the Delta mouse is just the change from your mouse movements, X and Y. I used it here as an event because when we tried to read it in the update, it was always 0. I'm not quite sure why that is, but running it this way works just fine. We are doing some quaternion math in order to get our cube to move in relation to our camera. And what we're doing here in our update is we're just grabbing the main camera rotation, we're getting its forward direction, normalizing it, using some funky quaternion math here in order to get the relative direction. And then we'll just apply that to our movement input here. Our look for our actual mouse movement here, we are clamping the Y up and down so we don't actually flip upside down if we go too high or too low. You don't want to go like below the ground and flip back around the other side. So we're clamping it here on the X and Y, our horizontal side to side. We're using Fmod, which will loop the X component so we don't get into like some weird like gimbal locking thing. So if we keep going to the right, it will just keep spinning. Our fired here, we just have this test just to make sure we're not firing multiple times per frame. Afterwards, we just set it that we have fired, and then we'll reset our look vector. And that is just to keep it from still moving when we stop moving our mouse. Our character here didn't end up using most of these, but this is just for the character, it is just a regular component data. Unity's example code has this broken out as an actual like full-on character controller, which I didn't need for this simple sample, but it does have a move speed, whether you're grounded, and when you started a jump. I think next video, I think we'll go over the actual full character controller. But for now, all I needed was just our move speed, and I'm just setting it here. The aspect, I mentioned that before. Our aspect here just lets us group a bunch of components together and basically query them all at the same time. When we query our character, we would want our input, the ghost owner, the velocity, all this good stuff. We'd want all of those all the time anyways. So instead of querying each one of these individually, we just query the character aspect, and then we get all this. And these are just simple properties just to make grabbing these components a little bit easier. Our movement here has not changed, I don't believe, much. Here we are still using the predicted ghost with a type of simulate. During the rollback, this simulate tag gets removed, so you don't end up moving twice while the rollback simulation is happening. The same for your like button inputs and stuff. You don't want those re-triggering every time new server packets come in. Here, we don't actually change anything. We are just grabbing the character aspect. And from here, we're getting the aspect input movement, X and Y. Normalizing it again. I don't think normalizing it twice is necessary. But then we just multiply it by our config move speed, and we're still using the linear velocity. The explode job is still there. Technically, that system is still running, but it's not actually doing anything at the moment. The camera system, this one is only running on the client, since the server obviously does not have a camera. It is in the presentation group and is running after that. We have our offset, which is where we want the camera to actually be. This could be, probably should be, a variable that we set that we can change, maybe with like a scroll wheel or something, we can change these. But that's something for later. Here, we're just grabbing the camera again, querying our character aspect, making sure it's only our local ghost that is affecting our camera. We do our funky math here again in order to get the camera rotation from our mouse delta. Rotate on the Y, rotate on the X. Then we will rotate the camera with our offset, and that will end up being our position. All right, so the actual meat of this scene is the actual shooting system. So each character will have a hit scan component, which is going to be the target that we shot, the tick that we shot, and the hit where we actually shot our target. All right, so the shooting system does happen in our predicted simulation system group. So it is going to roll back as well as be on the client and on the server. We are going to grab a whole lot of singletons and lookups here. The collision history, I mentioned this before as the physics world history. This is the collision states of the world where all the colliders and stuff are during the past. And in the config here in our rollback scene here, we have in the Netcode physics config, you will have to have lag compensation checked. So this will enable that system. And there's the size of the history, which is, actually don't know what the max size of that actually is. On the client side, I think it just goes back one tick, which is, depending on how many frames that is, here on the client side. And we talked about this last time, but you can have multiple physics worlds. So you would need to know which one that you're actually in. We only have one, so that's all we need to know about. So yeah, we're gonna grab the singleton for the physics world history singleton, the physics world, our network time. We'll get a component lookup for all of the ghost instances. There's not too many. I think in ours is just our player and our target. The scale, this is the post-transform matrix. We're using this because of how we're displaying those hit markers. They are technically UI components that are being spawned on the screen space canvas. There's probably easier ways of doing this, but this is the way from the Netcode and for entity samples use this, so I used it. This rollback enabled from entity component. This is what we're using for our toggle. The toggle checkpoint will enable and disable this component, and then our predicting tick. So this is from our network time. This is kind of important here. So this will only run when this is the first time our system is fully predicting this. So this won't run during the rollback resimulations. So our shooting system will only run once on the client side, once on the server side. Here in our query, we're querying just our server aspect. The command data interpolation delay. This is actually set on the ghost here. Down in our ghost authoring component, we have this track interpolation delay. This is basically just your ping time. So every tick, this is going to be sent out with all of your command data and stuff, and this will just basically tell the system how much your ping delay is, so it knows how much to roll back in order to get the correct collision state of the world at that time. Then we'll get all of our hits, and this will also ensure that it is only running on this simulated components. This I never actually, I think I got around to actually doing this part, but this was if you right clicked, it will basically shoot yourself, and you'll be able to see the delay that way as well. Here, if we are not set, we're just going to continue and just bail out of this current function onto the next one. This is kind of where the magic happens here with regards to rollback. So if we are enabled, we will grab the interpolation delay. This is what's going to be set by the ghost component. And if we are not enabled here with rollback, it will set the delay to 0. Here, we will grab the physics world history singleton, call the function get collision world from tick. So this will be at that tick, 207, if you recall from the picture, minus the delay. So it will go back however many milliseconds. It will reference the physics world, which I don't think is actually doing anything for us here, and then output into our a collision world, which is where we actually go through here and call a raycast on it. So the actual raycast here, we will need to get our camera. So we do grab our camera rotation and position. We're going to get the forward vector from our camera, which is going to be directly the center of our screen. And then we create a new raycast input. All that needs is a start, an end, which is going to be 1,000 units forward, and we have a collision filter. So if you want to exclude anything, you would use this collision filter for it. Sometimes when you're shooting, if your camera is, behind the player, you don't want to shoot your own player. You'd have a collision filter to filter out your own mesh from your raycast. And then we just call from the collision world that we got from here, we just call our cast, our input, and then we'll output the closest hit. If we don't hit anything, we just bail out. But if we do hit here, we will grab the hit point, and then we will check to see if this component has a ghost. And then we will basically get the rigid body from this entity, subtract the position from our hit point. The hit point is, I believe that's in like a local space for that object. So we'll take the basically center of mass from that rigid body position, subtract out the hit point. This multiplication here will get us the rotation that it is on. I think like the normal of that. Then we will scale it, and don't really have to worry about this, but this is because what we're spawning are sprites on our heads up display in our canvas. So we just need to scale it right and make sure that it is positioned correctly. And then we'll dump these out into our hit component, which is what our hit marker system will use in order to display on our screens. So here we're going to actually apply the hit marks that we just made. So again, this is going to be in our prediction group. This is going to be after our shooting system. You have to make sure that it is after, or else you won't have anything to actually hit. See, we again make sure that it is only in the first full prediction tick. And then we just, if we are the server, we will grab our server hit markers, which was the red plus, and apply it. Otherwise, it'll be the green check mark here. All right, so this is what's actually going to display the hit mark system. So this is only going to be on our client because the client's the only one that's going to have a canvas for us to display it on. We also need to make sure that this is after our camera system, so all of the rotations and positions of the hit marks are going to be in relation to our camera. So here we're going to get references to our prefabs, our canvas. We have a list of the hit information, the rect transform for the canvas, and then actual prefabs. I'm not sure why I have those separated like that. That's weird. All right, so first thing we'll do is on our update, we're just to make sure that we actually have a canvas and that we can find the game objects we're going to spawn here, which is just the red plus, green X. That's it. We're going to have a lookup for all of our positions, and we'll have two different for each loops going on. One for our server hit markers, We'll just loop through, instantiate each of them. We do the same thing with our client hit marker. Just loop through, instantiate them. We will need a reference to the camera. We go through all of the hit information that we grabbed. We'll need to grab the position of our target, grab the world position of it, and then basically scale those sprites down, make sure that they are rotated in the right direction. And then if they are more than 1 second old, we automatically destroy them. And that's what we do here. Down here with our spawn hit mark, basically this is just taking the game prefab, instantiating it, applying our information from our apply hit mark system, and then we'll add it to our hit informations that we will later go through and destroy. And this has hit mark yet will basically be when the server gets an update from the client. Since the client is technically a couple of ticks ahead of the server, it will actually have hit yet. And that's basically it. This is our move system for our target. Since the targets are going to be interpolated, they are just running on the server side. And basically it is just taking the transform of our weapon's target, moving it from the target speed back and forth. So if we have moved beyond the move range here, then it will just reverse the speed, and then it'll go back the opposite direction until it hits the opposite end of the move range, and then reverse directions again. We can look here at how the actual hit marker system works. It is kind of interesting. Nope, I need to go back to the main menu. Yep. Yep. Mm. This is also how you would end up doing health meters and stuff that would be above entities. If you wanted like combat spam for damage numbers popping off your characters, this would be a way to actually do that. So yeah. Next time, I think we are going to go over the character controller. That is here. The character controller used to be called Rival Character Controller on the asset store. I don't know if it's actually still there or not. Dots character. But they got bought by Unity last year, and it is not rival. Nope, guess they took it off. But it is now a package called, there we go, character controller. And it has a first-person character setup, third-person character setup, and apparently not too difficult to get set up networking. So I'll see how far I can get with that. And yeah, that's something to look forward to. So yeah, if you guys have any questions regarding Rollback or Raycast or anything like that, definitely leave us a comment below, and we'll see if we can help you out. All right, see you guys next time.